Good evening. I'm coming on the air with something that, honestly, has a lot of people in the space world sitting up a little straighter tonight. And I want you to lean in with me, because this story is one of those rare ones where the headline sounds like science fiction, but the data is real. The telescopes are real, and the questions we're facing are very, very real. Out beyond the familiar neighborhood of our solar system, there's an object tearing through space that doesn't belong here. It wasn't born around our sun. It didn't spend billions of years orbiting quietly between Mars and Jupiter or out in the Kuiper Belt. No, this thing is an interstellar visitor, something that drifted in from another star system and just happens to cross our path. Scientists have tagged it 3I Atlas, meaning it's the third confirmed interstellar object ever detected passing through our system. Only the third. Think about that for a second. In all of human history, in all the time we've been looking up, we've only caught 3 of these outsiders. That alone makes this a big deal. But now, 3I Atlas is doing something that has astronomers scratching their heads so hard they're basically leaving dents in their helmets. This week, researchers took a new ultra-detailed image of it, one of the sharpest looks we've ever gotten. And in that picture, there are features that just don't line up with what we'd expect if this were a normal comet or asteroid. I'm going to walk you through it in plain English, because you don't need a PhD to understand why this is weird. You just need curiosity. Picture a comet. You've seen them in movies, maybe even in the sky. A bright head, with a tail streaming behind it like a glowing scarf. That tail forms because the sun heats up the icy surface, turning some of it into gas and dust. Solar wind then pushes that stuff away. So you get this classic tail behind the comet look. Simple, predictable. That's not what this new image shows. What astronomers saw were 2 razor-thin, straight streaks extending away from the object in opposite directions, almost like somebody drew fine chalk lines in space. These lines weren't trailing behind 3I Atlas the way a normal tail would. They weren't even angled in the direction sunlight should push material. They shot out sideways, forming a kind of eerie X shape when you look at the full silhouette. Now here's where it gets interesting. Comets can produce jets, little bursts of gas and dust that shoot out from weak spots on the surface. But jets usually wobble. Why? Because the comet is spinning. Imagine a garden sprinkler. The water doesn't make a perfectly straight line. It arcs and sweeps because the sprinkler rotates. Same idea in space. If 3I Atlas were shooting jets while rotating, we'd expect those streaks to curve, or at least look uneven. But these lines are dead straight. No waviness, no smearing, like laser tight. So scientists are staring at the data and asking 2 huge questions. 1, if this object is spinning, how are those streaks staying so straight? 2, why are they coming out sideways instead of being pushed back by the sun like normal comet material? Those aren't small questions. They're the kind that can force you to redraw the diagram in your head of what's actually happening out there. And right now, the honest answer is, nobody knows for sure. But there are leading theories, and some of them are, well, they're pretty wild. The simplest explanation being floated, and I want to stress simplest, not necessarily right, is that those thin lines might not be jets at all. They could be trails left by fragments, little pieces that broke off the main body. Think of a chunk of ice cracking and tiny shards flying off in straight paths. If that happened recently, the fragments could leave faint streaks that look like lines. That's not crazy. Comets break apart all the time. They heat up, they crack, they shed material. But this breakup, if that's what it is, would have to be unusually clean and unusually fast. The fragments would have to be moving away at extreme speed to produce lines that long and that straight. We're talking speeds that are hard to get from simple heating and cracking alone. And that brings us to the second possibility. I'm not saying it's true. I'm saying it's on the table because the physics demands we at least consider it. What if those fragments weren't just debris, but were released intentionally? Like probes, like small objects separating from a parent craft. I know. I hear myself saying that out loud, and I know how it sounds. Stay with me. Here's why that idea even exists. If these streaks were caused by fragments, The math suggests those fragments would have to be moving at a blistering pace relative to the main object, in the range of hundreds of miles per second. That is fast. That's not a comet crumbling in the sunshine fast. That's something got flung out with serious force fast. Now, could nature do that? Maybe. There are exotic natural processes, volatile gas pressure, explosive fracturing, weird rotational stresses, sudden outgassing that acts like a jet engine. Space is full of surprises, but those processes usually produce messy, fan-shaped plumes, not two perfectly pencil-thin lines in opposite directions. And another detail, the sun's gravity can't explain a sideways push like this. Gravity pulls inward, not sideways. Solar wind pushes outward in a flow. Neither of those naturally makes a neat 90-degree spray unless something internal is driving it. So that's the fork in the road tonight. One path says, natural breakup with unusually high-speed fragments. The other says, something engineered, releasing small objects on purpose. Scientists are not declaring aliens. Don't hear that. They're saying, the data is strange enough that we need to keep the full range of explanations open. That's called doing your job. And there's one person in particular who's been vocal about this kind of open-minded approach. Harvard astrophysicist Avi Loeb has been following 3I Atlas closely and arguing that, just like with past interstellar visitors, we shouldn't assume we already know what we're seeing. He's not saying it's definitely artificial. He's saying, let's not lock ourselves into a story before we have all the evidence. Whether you agree with him or not, he's helped pull this conversation into the public square where it belongs. Let me say something here as your anchor, and as a regular human being who still gets goosebumps thinking about what's out there. The universe doesn't owe us simplicity. We're used to our cosmic backyard. We know the rules here. We've mapped out the planets, the asteroids, the comets. We can predict eclipses down to the minute. But then something from another star system strolls in like a stranger at a hometown barbecue. And suddenly we're reminded we don't know the whole story. Not even close. What makes this even more compelling is that 3I Atlas has been acting up for a while. Earlier observations hinted at unusual brightness changes and a weird glow pattern as it passed deeper into the inner solar system. Researchers noticed shapes around it that didn't fit cleanly into the usual comet playbook. And now, with this crisp new image, the questions are sharper than ever. The next step is verification. We have to be careful here because space images can include artifacts, like streaks from satellites or cosmic rays hitting a detector. Astronomers need to confirm those two lines are actually connected to 3I Atlas, and not something weird in the background or the camera system. They're already on it, comparing observations from multiple telescopes, different angles, different times. If multiple instruments see the same structure, it's real. If it disappears under scrutiny, then it was a false alarm. But if it's real, then this story gets bigger. Because natural or artificial, either way, it's telling us something important about interstellar objects. If it's natural, then maybe interstellar comets can fracture and release material in ways we haven't modeled yet. That means our understanding of comet chemistry and physics is incomplete. If it's artificial, if it turns out to be a technological fragment release, then we are looking at something far more profound. Evidence that something built elsewhere has crossed into our world. I'm not saying that's where this is headed. I'm saying that's why scientists are so careful right now. Because the stakes are huge, and the universe doesn't give us a lot of second chances to study visitors like this. And there's another reason this matters: timing. We're catching these interstellar objects because our instruments finally
got good enough. Surveys are sweeping the sky constantly now. We're faster, more sensitive, more coordinated. That means we might be entering an era where these discoveries become less like lightning strikes and more like routine science. Today, it's 3I Atlas. Tomorrow, it might be 4I. The next one, and the next. Each one a messenger from a distant, unknown star. So I want to bring this home for a second. Away from the math, away from the telescope jargon. What does it mean for you and me watching this from Earth? It means the universe is not a closed book. It's a live story. We're not just reading the last chapter, we're getting updates in real time. And sometimes, those updates arrive in the form of a tiny object streaking through deep space, carrying with it a record of conditions in another solar system, another time, maybe even another kind of cosmic history. That's humbling. That's thrilling. And honestly, that's a little scary, in the best possible way. Because when something surprises scientists, people who literally dedicate their lives to predicting what rocks and ice will do in space, that tells you we're standing on the edge of what we know. And guess what? That edge is where the biggest discoveries happen. Now, let me walk you through what researchers are watching for in the coming days and weeks. If these streaks are fragments, scientists want to see whether they keep moving outward, whether they fade, whether they multiply, or whether the main object shows signs of further cracking. Fragment trails should drift and spread with time. If we see that, it supports the natural breakup idea. If, on the other hand, those streaks behave more like controlled objects, holding formation, changing direction, showing non-gravitational acceleration, that would raise the eyebrows higher. Non-gravitational acceleration is a fancy way of saying it's moving as if something is pushing it besides gravity. That's rare in nature at these scales, unless you've got outgassing. So the pattern of motion is going to be a key clue. Another clue is spectrum analysis, basically breaking the light from the object into its component colors to see what chemicals are present. If it's natural, we should see signatures of familiar comet stuff: water vapor, carbon compounds, dust. If something looks engineered, we might see unusual materials or reflectivity patterns. Again, not declaring anything, just gathering evidence. And this is where I really want to emphasize the difference between speculation and science. Speculation is fun. It's human. It's what we do when faced with mystery. Science is the slow, disciplined process of deciding which speculation survives contact with reality. That's what's happening right now. The evidence is being gathered. The models are being run. The debates are happening in research groups and university halls and observatories all over the world. You might be thinking, okay,
But why should I care about some object that's millions of miles away? Fair question. Here's why. First, interstellar objects are basically time capsules. They formed around other stars. Studying them could tell us about how planets form elsewhere, what materials are common, what chemistry is possible. That helps us understand not just distant systems, but our own origins. Second, they're a test for our readiness. If something from interstellar space ever did come here on a purposeful trajectory, and I'm not saying that's happening now, we'd want to be able to detect it early and understand it quickly. Every interstellar visitor is a rehearsal for that kind of scientific response. Third, and maybe most importantly, stories like this change how we see ourselves. We live on this little blue dot, and for most of history we assumed the sky was a ceiling. Then we learned it's an ocean. Then we learned that ocean is connected to other oceans. And now we're starting to notice the driftwood from those other oceans washing up near our shores. That's what 3I Atlas is, driftwood from another cosmic beach. And we're looking at it, trying to figure out what kind of forest it came from. I want to make a subtle point here that I think matters. There's a temptation when we hear a story like this to either jump all the way to aliens or shut it down with, "It's obviously a comet, stop being dramatic." Both of those reactions miss the real beauty of the moment. The truth is in the middle. The truth is, we don't know yet, and that is okay. Not knowing is a feature, not a bug. It's the engine of discovery. We need mysteries like this to keep science alive and honest. We need moments where the universe says, "You sure you've got it all figured out?" And we look back and say, "Apparently not. Let's learn." So tonight, here's where I land. My point of view is simple. This object matters because it's forcing us to stay open-minded. The data is weird enough that we can't autopilot our assumptions. We have to let the evidence lead, even if it leads someplace unexpected. That doesn't mean believing every wild theory. It means being brave enough to consider possibilities without committing to them prematurely. If those streaks turn out to be debris, then nature just showed us a new trick. If they turn out to be something else, then we're in a moment that people will talk about long after you and I are gone. Either way, We're lucky to be alive when we can watch it unfold. And I'll tell you something else. I've been doing this job long enough to know that some stories are about facts, and some stories are about perspective. This one is both. The facts are still coming in. The perspective is already clear. Our universe is bigger, stranger, and more alive with surprise than we like to admit on a day-to-day basis. That's not a scare tactic. That's a gift. We'll keep tracking the observations as they come in. We'll bring you updates from the astronomers who are watching this thing night after night. And I promise you, we'll stay grounded, we'll stay honest, and we'll resist the urge to lock in a narrative until the sky itself corroborates it. But for now, take a second after this broadcast. Look up, if you can. You don't have to see 3-eye Atlas with your eyes to feel what it represents. Somewhere out there is a visitor that traveled unimaginable distance to pass through our neighborhood. And in doing so, it's reminding us of something deeply human. The unexpected is not a threat to knowledge. It's the doorway to it. I'm going to leave you with that tonight.